I would like to express my thanks to organizers of this conference, especially Dr. Sang Dal-shin and also the president of the KDI and the Professor Dong-Sung Chang, and also I appreciate the very kind introduction about me from Dr. Moon-suk. It's too much for me, and actually this is I'm not familiar with make a speech like this, so I usually I don't use mic. So the title of this paper is the transmission mechanism of the public debt. The reason why I choose this one is recently, as the economy accumulates high level of the debt, the public debt might have some important role in making some real impact. So that's why I choose the transmission mechanism of public debt. And here, this is the outline of my paper. The first point is, actually the first part of my paper is the empirical estimation of the empirical IS curve. Actually, I augmented the conventional New Keynesian IS curve with the public debt, and then try to estimate. Try to see what is the coefficient of the public debt in the augmented IS curve. In doing so, I use one-line equation, just the IS curve, and then try to make GMM estimation. And the other one is VAR projection method. This is just the extended of the first case, but I use unweighted vector regression estimation to get the coefficient of the public debt. And once I have the empirical result, I move on to what would be the implication of the augmented IS curve. Here, what I have in my estimation is just in the IS curve, the coefficient of the public debt is negative, which means that as the public debt increases, the debt suppress the aggregate demand. So that is not the Wells effect. So there is no Wells effect. Contrary to the Wells effect, the IS curve, the empirical IS curve that I have is the non-Wells effect. So, and then I put that the IS curve into the small DST model. So, and then try to what would be the implication for the determinacy of equilibrium path, and what would be the implications for the busy cycles. And in the third part, this is in the second part. I just used the prototypical type of the linearized the New Keynesian model. But here in the second part, I wanted to provide micro foundations for the IS curve with public debt, because I did not give any micro foundation for the IS curve. I just started with empirical IS curve, and then in the third part, one might be potentially possible the micro foundations for the IS curve, especially with negative coefficient of the public debt. So my conclusion is, if I add some kind of the financial friction, and the financial friction is dependent on the level of the public debt, then it might be possible for us to have the IS curve with negative coefficient of the public debt. That is, I think, brief summary of my paper. So here, these figures summarize my empirical motivation. So in the upper panel, there is the ratio of the public debt to GDP in the United States. It starts early 1980, and then until the 2011, 2012. So the solid line of the solid line in the upper panel is just the data, and then I used the H filter to get back out the trend, and then the dotted line is trend. So and then given that, I can extract the cyclical part of the ratio of the public debt to GDP. If you look at the lower part of the slide, the solid line is the detrended part of the ratio of the public debt to GDP. And also I plot the up gap in the same plot, the up gap here is defined as the difference of the log GDP and the log potential GDP. Potential GDP is downloaded from CBO website. And then as you look at the graph, you might be able, you can see the negative relation between the trend ratio of the debt to GDP and the up gap. So that is then my question is why we have the negative relation. There might be different, various reasons, various mechanisms that gives rise to the negative correlation between up gap and the detrend ratio of the GDP to the ratio of the debt to GDP. So here, what I choose is in this slide the IS curve estimation. Here, in the first line is conventional specification of IS curve. So this is just a linearized oil allocation. So here XT is the output gap, and the output gap is defined as the log of the GDP from its London, the potential GDP level. And XT plus 1 is the next period output gap. So in this specification, future the expected value of the future output gap affects current aggregate demand. Also, the aggregate demand that is measured by XP depends on the real interest rate. So RT is nominal interest rate, pi t plus 1 is next expected inflation, and RTN is just natural rate of interest. So this is the conventional specification of the IS curve that was used in Professor Lippers, the optimal power study. And then if you look at the second line, just if you compare the first line and with the second line, just I add one more term in the final term in the right hand side, just PPT head. PPT head is the log of the public debt to GDP ratio. And then what I want to do is I want to estimate the second equation by using the GMM method. So this is just a simple practice exercise of the and then what is result? So in this slide I just summarize some results that I have. So I use different measures of the output gap. In the first case, I used the real GDP, and then here, as you look at in the first line, the coefficient of BPT head is minus 0.27, and if I use also the personal consumption expenditure, the sign is the same. And the non-durable, in the second line, non-durable consumption expenditure, the coefficient is still negative. And also the coefficient of the interest rate gap is also negative. So that from this estimation result, I can see that the coefficient of the ratio of the debt to GDP consistently negative. So also in this case, rather than using the ratio of public debt, I just use the real public debt. But I just use the HB filter to back out the stationary part of the real debt. And then you see in this slide the coefficient of the debt are negative in these three cases. So this is the result that from the GMM estimation for the IS curve. So, but here this result might be might be spurious because this result might come from the actually the IS curve relation or the budget relation, because but here in order to see that whether or not this is really IS curve case or the budget relation, so I use this cross correlation because the negative relation comes from the budget relation. Then actually the budget equation is the difference equation for the debt. So if we compute the forward-looking solutions to this budget relation, then the current budget should be correlated with the future output gap. And also, if really this relation comes from the IS curve, if you look at this one, this is actually the differentiation for the output. So if we look at solve this one, then we can find the forward-looking solution that express the current output gap in terms of the future debt. So here, this is the current the relation between the current output to the future GDP ratio if we move to from the 0 to 1, 2, 3, 4, and then here we can see the relation, the correlation between the current GDP to debt ratio is cross correlation is negative, but the other side is just positive. So this cross correlation relation tells us that the negative correlation might comes from the IS relation. So, and then I move on to another method to see if we still have the same coefficient, the sign of the coefficient. So here, in the first part, I estimated the unrestricted vector integration in this projection method. So in the vector integration estimation, the vector includes output gap and interest rate gap and the ratio of the public debt to GDP. And then given this estimation, I formed a state space representation, as you look at in the second equation. And then I impose the IS equation relation into the state space representation to derive the the model-based output gap. And then this is the FTF. XTF is the model-based output gap, and also we have the actual output gap. As you see here, the tilde T includes XT. So we have actually the actual measure of the output gap, and then we have the model-based measure of the output gap and the actual output gap. We have the difference between actual and the fundamental output gaps as you look at bullet point 3. So, and then given that I estimate the minimum distance estimate by minimizing the weighted, minimizing the difference between model-based output gap and actual output gap. So, and then what is the result? The coefficient, the debt coefficient is still negative, and also the coefficient of the interest gap is still negative. So 0.68 is the coefficient of interest rate, and the 0.19 is the coefficient for the debt. And also, what I found is the very high correlation between actual and the model-based outcomes, correlation of 0.89. As you look at see here, the blue line represent the model-based outgap, and that comes from the IS curve restriction, and also the actual measure of the outgap is the red dotted line. So the model-based outgap mimics closely the actual outgap. That is my result for the estimation of the IS curve. And then given this result, what I think is what would be the implication of the empirical IS curve for small ds model. So here, what I did is just I put the IS curve with public debt into the prototypical New Keynesian model. So the first line is the IS curve. The only difference from the prototypical the specification of the New Keynesian model that is in the Woodford textbook is just BT hat. That is included. And once we include BT hat in the IS curve, we need more equations, because the typical one is, as Professor Lieber said, under the Great War policy, we just need 3 equations. And one is IS curve, the other one is in the second line is a Phillips curve, and the third one is just a tailored type of interest rate group. But once we have the debt variable in the IS curve, we need 2 more equations, because that is included in the IS curve. So one is how the first line is the linearized equation of the government budget constraint that gives us the evolution equation for the BT. And then once we have the fourth equation, we need one more equation to see what is the evolution of ST. ST means the primary deficit here. So the government's fiscal policy is expressed in terms of the ST primary deficit. So that is the fifth line. So we have these 5 equations to understand what would be the implication of the IS curve with negative public debt. So, and then here we might need the distinction between Ricardian and the non-Ricardian fiscal policy region once we have the variables in the equation system. So the first one here, what I try to say is what would be the distinction between Ricardian fiscal and the non-Ricardian fiscal policy. As you can see, as you look in the second point, Ricardian fiscal policy is just the changes in the current period's primary deficit surplus are offset by the changes in future budget surplus in order to satisfy the government's present budget constraint, irrespective of past, of current, and the future price levels. So this is just a passive fiscal policy in terms of the recourse in the framework. And then, but here, the non-Ricardian fiscal policy, just the fiscal policy does not look at changes in the economic condition, just exogenously determine the real budget surplus. So this is the non-Ricardian fiscal policy. And then here, once we have this is the equilibrium dynamics that's summarized in the matrix equations. So once we don't, here in the case of the Ricardian fiscal policy region, actually here the sum matrix A is only sufficient to understand what would be equilibrium dynamics. But once we allow for the possibility of the non-Ricardian fiscal policy region, so we need a matrix, sum matrix D and B and C. So there is an interaction between, in this case, interactions between sum matrix A and D. So what is the result here? So just I will summarize the result. So in the case of the in the IS curve with negative public debt. So in order to have the unique bounded stationary path, so Taylor pretty simple. And in the case of the monetary policy, in the case of fiscal policy, we need non-Ricardian fiscal policy regime. So that is contrary to the conventional result, because in order to have a unique bounded stationary solution, we need active monetary policy and passive fiscal policy, which corresponds to here the Ricardian fiscal policy regime. But once we have negative coefficient of the public debt in the IS curve, then the conditions that guarantees the unique bounded stationary solution changes. That is, I think, then my summary, my result, and also we have a little bit difference in terms of the business cycle impact. So if you the IS curve with negative coefficient of public debt here corresponds to non-LC effect. So in this case, what is the difference? So if you look at the lower panel of this one, so in the case of the exogenous budget consolidation case, the impact is output increase and the inflation increase in the case of the IS curve with negative public debt, but in the conventional case, output decrease and the inflation decrease. So also there is a difference in terms of the business cycle impact of the exogenous shocks. So, and then what will be micro foundation for the IS curve with public debt? Just there are a bunch of the different mechanisms that give rise to negative public debt in the IS curve, but I just want to introduce one case here. So, financial market friction. So there are primary and secondary markets for the government securities. What is the financial friction? There is an entry barrier for participants of the primary market who can act as primary dealers. So participants of the secondary market are retail banks, and the monopoly profits from the dealing with government securities can arise in the presence of the sovereign default risk. Given this market structure, sovereign default risk could be transferred to the participants of the secondary market. So just the wholesale market wholesaler just transfer the potential possible loss to the retailers. So, and also the interest rate is applied household depends on the interest rate of the retail banks. And then given that, and then we have the nodal linearized model, we have the same type of the IS curve equation that we have from the data. So that is, I think, that one possible micro foundation for the IS curve with a negative coefficient of public debt. So this is my brief summary of my result. So multiple distinct channels might exist in the way through which the public debt affects the aggregate demand, and the financial friction channel of the public debt may help explain how a rise in the public debt can repress the aggregate demand, especially in the area of persistently high levels of the public debt. Main mechanism of the public debt is not fixed over time, rather it seems likely to change over time. Once the financial friction channel of the public debt begins to work, it dramatically changes the nature of the interactions between monetary and fiscal policies. That is, I think, the brief summary of my research. This wraps up my presentation. Thank you very much.